So in the last class, we have discussed about what is gear, what is the function of gear, what are the different types of gears, and we have discussed about what is worm gear, what is the function, applications, advantages, disadvantages, and all. So today we'll discuss the terminologies of the worm gear. See, whatever the figure you are seeing, figure A, figure B, and figure C, this is the worm gear. So already I told that the worm or the pinion. The worm or the pinion. See,
Hello, sir.
this is the topmost is nothing but worm. This is nothing but worm wheel. Understood? The worm having number of threads. The worm gear having number of
Threads. Tooth, sir. Teeth.
teeth. Worm having number of threads or
Threads.
pinion. The worm wheel having number of teeth. See, there are different types of threads you are having. In CAMD, you have studied different types of threads. And also, in the DME1, in design of screw jack, right? What is the design of screw jack?
Yes, sir.
There,
Yes.
you have heard the name of lead. What is the lead? L is equal to P, L is equal to 2P,
Yes, sir.
L is equal to
Yes, sir.
3P, like that.
Yes, sir.
Where
Last
lead is
last
equal to pitch,
Yes, sir.
lead is equal to 2 times of pitch, lead is equal to 3 times of pitch, lead is equal to n times of pitch, like that for the thread. So same thing here. So this is the worm. This is the worm having number of threads.
teeth.
So here the distance from here to here we call it as P or we call it as lead. And should the distance from one thread to the another thread is nothing but pitch or we can call it as lead. And the threads are cut with some angle. The threads are cut with some angle. That slope is called it as gamma. We can call it as lead angle, gamma. So figure A is nothing but shows a single thread. Figure A shows a single thread worm or single start worm. If you see figure B, see here, lead is equal to pitch. It is having same distance. P is equal to lead. But if you see the figure B, lead is equal to any there. See figure B, lead is equal to how much? Huh?
2P.
2 times of pitch. The distance from one teeth to the another teeth is nothing but pitch. So addition of 2 pitches is nothing but lead. So here we call it as lead is equal to 2 times of pitch. Next for third figure, lead is equal to 3 times of pitch or 4 times of pitch. So therefore, figure A is nothing but single start, figure B is nothing but double start, figure C is nothing but triple start or n number of starts. And sure. And gamma is nothing but lead angle, that is the slope of the thread. Allah consider this figure.
Sir. Sir, yes, sir.
So here, so same thing,
Sir,
worm
voice
we have
break
taken,
out
worm
today,
gear
sir.
we have taken. So here we are on the worm pitch diameter. So from here
Hello?
to here we call it as worm pitch diameter.
Hello?
And we can see this angle is nothing but gamma, lead angle. And actual pitch, the distance from one end of the
Hello?
pitch to the another end of the pitch is nothing but actual pitch. And sure. So now we will see the definition. So first we'll see what is lead. It is the amount the helix advises actually for one turn about the pitch cylinder, and it is equal to the number of thread times the P. That is nothing but for one complete rotation is nothing but pitch. So therefore lead is equal to LP, or lead is equal to 2 times of pitch, or lead is equal to 3, or lead is equal to n times of pitch. So always lead depends upon the pitch or distance from one thread to the another thread. Next, so the formula to calculate lead. Lead Pz is equal to Px into Z1, where Pz is the lead, Px is equal to axial pitch, Z1 is equal to number of threads or starts on the worm. So Px can be written as pi into mx. So in Spurgers you have studied P is equal to pi into m. You substitute ಮಾಡಿದ್ರಲ್ಲ in formulas.
Yes,
Sigma
sir.
naught in the Levis equation formula, you will get P.
Yes,
There you are
sir.
substituting P is equal to m pi into m.
Yes, sir.
Same thing here. Px is equal to pi into mx. So from this equation you will get 23.528. Next, lead angle. I told that lead angle is nothing but gamma. Lead angle is the slope of the thread is called as lead angle. The slope of the thread we will call it as lead angle, and that angle can be calculated by using the formula tan gamma is equal to Pz divided by pi d1.
Pi d1.
We are going to calculate gamma. Therefore, gamma is equal to tan inverse of Pz divided by pi d1. What is Pz here? ಮೇಲೆ ಕಾಣಿಸಿದೆ ನೋಡಿ Pz.
Lead. Yes, sir. Lead.
Pz is equal to lead, and d1 is the pitch diameter of the worm. And sure, therefore gamma is equal to Pz divided by pi d1. Next, another formula, center distance. So a center distance can be calculated by using the formula d1 plus d2 by 2. d2 is the pitch diameter of the worm gear or worm plane. Next is circular pitch. The formula to calculate circular pitch P is equal to pi d2 divided by z2. So here the circular pitch of the worm gear must be same as that of the axial pitch. So as in this Spurgers, what same thing here also, circular pitch is equal to axial pitch, and it can be calculated by using the formula P is equal to pi d2 divided by z2, where z2 is equal to number of teeth on worm gear. And should for worm gear you will get number of teeth, then pit code. And another formula, velocity ratio I is equal to n1 by n2 is equal to z2 by z1 is equal to pi d2 divided by pz. So that you will get from the equation number 23.53. These are some of the notations of nomenclature. So next we are going to discuss formulas. So any doubt here?
No, sir.
So next, so same thing I have explained in the video, whatever thing I have uploaded yesterday. Once again you go through that video.
Okay, sir.
Okay, sir.
So here, next is strength of worm gear. Understood? So you tell that in Spurgers, you are designing for pinion or you are designing for gear? Problems?
Both.
Both.
Dear sir.
Gear. Why you will design for gear? Why you are not designing for pinion?
Don't know, sir.
According to the weaker member.
See, in Spurgers, depending upon the weaker member you will get. Correct?
Yes, sir.
You will calculate which is the weaker member or weaker component. It may be pinion or it may be gear.
Gear.
Whichever you will get weaker member, for that weaker member you are doing the complete design. Understood?
Yes, sir.
ಅರ್ಥ ಆಯ್ತೇನ್ರಾ?
Yes, sir.
And also
Yes, sir.
in Spurgers, if the material is same for pinion and gear, we are not calculating weaker member. Directly we are designing for the pinion as the weaker.
Opinion. Yes, sir.
Same thing in the worm gears, we are not calculating the weaker member. Always we are considered worm wheel. ಇಲ್ಲಿ ನೋಡಿ ತೋರಿಸಿದರೆ as always worm wheel is the weaker member. Understood what I am telling?
Okay, sir.
Always we are designing for the worm wheel. Worm wheel ಅಂದ್ರೆ ಯಾವುದು? See, this is nothing but worm wheel bottom one. Teeth ಇದೆ ಅಲ್ವಾ, number of teeth wheel ತರ ಕಾಣಿಸ್ತಿದೆಯಲ್ವಾ?
Yes,
Yes,
sir.
sir. Yes,
This
sir.
is nothing but worm wheel. Always this is the weaker member. So therefore always we are doing design for this weaker member. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ?
Yes, sir.
So design should be based on worm wheel. First we have to calculate strength formulas. We are going to calculate the strength of the worm wheel. First, strength of the worm wheel based on Levy's equation. So Levy's has given one equation. Based on that, we are going to calculate the strength. The formula Ft2 is equal to sigma naught to B Mn y into Cv. Why here they have mentioned 2?
Sir, worm wheel.
ಏನದು 2 ಅಂದ್ರೆ what it indicates?
Gear, no, sir.
So always we are designing for the gear, right? Worm wheel.
Yes, sir.
Always
Gear.
for wheel or gear we are representing by 2 2 2 2. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? If it
Yes,
is
sir.
pinion, it is represented by 1 1 1 1. ಅರ್ಥ ಆಯ್ತೇನ್ರಾ?
Yes, sir.
So
ಇಲ್ಲ ಸರ್,
therefore
ನೋ ಸರ್,
ಏನಾ
ಅರ್ಥ ಆಗಿಲ್ಲ ಸರ್.
ಯಾವುದು?
ಅದೇ 1 1 ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್.
See here,
That's pinion for.
you are having pinion and gear. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ?
ಓಕೆ ಸರ್.
For pinion, always we will represent Z1, D1, N1 like that. 1 1 1. ಅರ್ಥ ಆಯ್ತೇನಾ?
ಸರ್.
For gear, we are representing by Z2, N2, D2, Ft2. Represent by 2. 2 represent always for gear.
ಹಾಂ ಸರ್.
That's the same thing. Here Ft2 is nothing but for gear Ft2 is equal to sigma naught to B by Mn y into Cv. Here capital Y is nothing but Levy's form factor and it can be calculated by using the formula pi into small y2. Mn is nothing but normal module and B can be calculated by using the number of threads. See, B is equal to less than 0.715D if Z1 is equal to 1 to 3 and B is equal to less than 0.67D if Z1 is equal to 4. So you will calculate Z1 first. Based upon the value you will get Z, you are going to take these two formulas. Artha aita?
Sir.
Next, sigma naught 2 is the allowable
Yes,
static stress of the worm wheel. So from the table 23.96 we are taking and Cv directly we are calculating by using the formula 6 divided by 6 plus Vm. From this equation numbers or tables you will get all these formulas. This is the formula given by the Levy's equation. Artha ಆಗ್ತಿದೆಯೇನ್ರಾ?
Yes, sir.
ಓಕೆ ಸರ್.
Next is tangential tooth load. You know the formula 9550 into 1000 into n into cs divided by n2 into r2. So directly we are taking here n2 r2. Y means we are designing for the gear and cs is nothing but service factor and n is the speed of the gear, r is the diameter of the worm wheel and velocity can be calculated by using the formula pi d2 n2 divided by 60,000.
60,000.
Yes, sir.
So these are the two formulas, the calculation of tangential load by using Levy's equation and tangential tooth load. Next is dynamic load. Same thing also you have calculated in Spurgers, right?
Yes, sir.
Yes, sir.
There are different formulas. Now, dynamic load. So the formula of dynamic load is very simple. So Ft is equal to 6 plus 6 Vm divided by 6 into Ft, or I can write it as Ft divided by Cv. See here you can see the formula of Cv. See 6 divided by 6 plus Vm, correct? If you see here Fd formula 6 plus 6 by Vm, so reciprocal. Therefore,
Okay, sir.
you will get Ft divided by Cv. So Ft is the actual transmitted load. Cv is the velocity factor. Understood? Next, another formula is endurance strength. So endurance strength also based on the Levis equation. So it is also same formula, sigma naught to B Y2 pi into Mn. Here you won't get Cv. That is the only thing. You will get the endurance strength. Next is bear load. So next bear load. So according to the Buckingham's equation, so this bear load formula is given by Buckingham's. The bear load Fw is equal to D2 B into K. So always here you have to take D2 only. Artha agtideya? So
Okay.
D2 is the pitch circle diameter of the worm gear, B is the face width, and K is the load stress factor. From the table 23.100 we are taking the value of K and we are calculating the Fw. So this is the formula to calculate bear load. So these are the same thing you have calculated in Spurgear. So there also you have calculated Ft based on Levis equation, Ft based on tangential load, dynamic load you have calculated, and endurance strength you have calculated, bear load you have calculated. Correct?
Yes, sir.
But after
Yes, sir.
calculating all these things, in Spurgears, we are calculating the hardness. But here we are not calculating the hardness. We are calculating the values of dynamic load. What is how much dynamic load is acting, how much wear load is acting, and how much endurance strength is acting. After that, we are going to calculate efficiency. Already in the last session, I told that the disadvantage of the worm gear is efficiency, less efficiency due to high heat transfer or high heat generated. Correct?
Yes, sir.
Yesterday I told you the disadvantage. So therefore, we are going to calculate the efficiency. So efficiency can be defined as the ratio of output power to the input power. You know the formula of efficiency, output divided by input. Here, there are two formulas to calculate efficiency. So first formula, see here, efficiency when the worm drives the worm gear. Here, worm is the driver, worm gear is the driven.
Yes, sir.
Understood? At that time, you have to use this formula to calculate efficiency from the equation number 23.604H. Another formula, efficiency when worm gear is the driver and worm is the driven. And this is the another formula you have to use when worm gear is the driver. By using these two formulas, we are going to calculate the efficiency. In question, they will mention worm is the driver or worm gear is the driver. Or sometimes they won't give. We are going to assume which is the driver and which is the driven. Based on that, we are taking the formula of efficiency. Understood? Idirena?
Yes, sir.
Yes, sir. Yes, sir.
So here, so before calculating efficiency, we will get unknown, that is nothing but alpha. Alpha n is equal to normal pressure angle, gamma is equal to lead angle. So alpha, at the beginning you will calculate, gamma at the beginning you will calculate, unknown is mu, that is nothing but coefficient of friction. The mu can be calculated based upon the rubbing velocity, VR. VR is nothing but rubbing velocity, that is equal to pi d1 n1 divided by 60,000 into cos gamma. So based on VR you will get, you are going to take the formula of mu. See, these are the two formulas from the equation number 23.570A, 23.570C, based upon the mu r. If rubbing velocity VR is greater than 0.2, less than 2.75, this is the formula you are going to use. If VR is greater than 2.75, less than 20, then you are going to take second formula to calculate mu. So based on VR, you are taking the mu, then you are substituting and you are calculating the efficiency. So then that way we are going to calculate the efficiency of the worm gear. Next is heat generated. And should always see, here they told that in worm gearing, the heat generated due to work lost in friction must be dissipated in order to avoid overheating of the driver and the lubricating oil. So now we are going to calculate how much amount of heat is generated and how much amount of heat is coming out of the gear.
Gear.
Should see, below they told that
Yes.
the heat generated must be dissipated through the lubricating oil. Always you know that the oils are used to reduce the heat, right? So here
Yes, sir.
they are using lubricating oil, through lubricating oil to the gearbox housing and the atmosphere. The heat is coming out from the oil, then it is transferred into the gearbox, then it is coming out to the atmosphere. So because of that, so the heat dissipated capacity depends upon the rate of housing, temperature difference between the housing surface and surrounding air, and the heat transfer coefficient. Based upon these three things, the heat dissipated will be depends. So now first we will see heat generated. Hg is equal to mu Fn VR divided by 1000. This is the formula to calculate heat generated. Here mu in the previous step you will calculate, VR in the previous step you will calculate. Only unknown is Fn, where Fn is nothing but normal force that can be calculated by using the formula Ft2 divided by cos gamma into cos alpha.
Cos alpha.
And sure. Next, heat dissipated. Heat dissipated can be calculated by using the formula HCr into A, Tg minus Ta divided by 1000. So already I
1000.
told that here, I told that heat dissipated depends upon three conditions: based upon the area, based upon the temperature difference, and based upon the heat transfer coefficient. So therefore, here HCr is nothing but Cr, coefficient of heat transfer, from the figure you will get 2.89. A is nothing but radiating area of housing, and it can be calculated by using the formula 14.4 A to the power of 1.7. Tg is nothing but temperature of gear. Ta is nothing but ambient or room temperature. So by using this formula, we are going to calculate heat dissipated. Understood?
Yes, sir.
Yes, sir.
So by using these two formulas, we have calculated heat generated and heat dissipated. Now I will ask one question. If heat generated is less than heat dissipated, then artificial cooling is required or not?
Artificial cooling required, sir.
Required, sir.
So required, right? So
Yes, sir.
always
Yes, sir.
when heat is generated more compared to the heat coming, then we are going to use some artificial cooling by using some fans or some cooling system. And sure, so that we are going to calculate in the problems. Artha aita?
Yes,
Okay,
sir.
sir.
So next, so these are the things we are going to calculate. So we are calculating the tangential load, VL load, dynamic load, endurance strength, and efficiency, and heat generated and heat dissipated. And sure. So next we'll see some of the notations. Already you know that Z1 is the number of starts, number of threads. Z2 is the number of teeth on worm wheel. M is the module. Q is the diametrical quotient, and it can be calculated by using formula D1 by M. D1 is the pitch circle diameter of worm. Directly we can calculate D1 by using the formula A is equal to 0.875 divided by 1.5. So this D1 formula I will get from the equation number 23.544A. And D2 is equal to pitch circle diameter of worm wheel. It is equal to M into Z2. Px is equal to axial pitch. Pz is equal to lead. Gamma is equal to lead angle. So these are the notations and formulas. Already we have discussed this, all the things. Next. So this is the table to calculate K. I will tell where you have to calculate this K. This